This is problem 4b. Find the volume obtained by rotating area bounded by y equals x squared and y equals x, or round x equals 0. So the first thing you want to do is find the intervals in which these two cross. So you would do that by setting them equal to each other. So x squared equals x. And then get the x's on one side. X squared minus x equals 0. Solve for x, you can pull out an x. It becomes x equal x parenthesis x minus 1 equals 0. So x equals 0 and x equals 1. It's a bit of a glare, but this will be A, this is going to be B. And so the bigger function out of these two is the bigger function within this boundary is going to be y equals x. So this one is going to be, this one's going to be f of x. This one's going to be g of x because it's smaller within the boundaries of A and B. On a graph, it would look something like this is y equals x. This would be y equals x squared. So the curved one is x squared, the line is x. So as you can see, it's above, which would make it the f of x function, the bigger function in the interval. And then it's going to be rotating around x equals 0 or the y-axis. So the formula that we use for this is the formula for shells, which is volume equals the integral from a to b of 2 pi x minus L times f of x dx minus integral of a to b 2 pi x minus L g of x, which is the smaller function. And now, so a equals 0, b equals 1. L is where L represents the axis which it's being shifted around. Since it's being shifted around the x-axis, it would be 0, x is 0. So now we just plug in volume equals integral from 0 to 1 2 pi x, because L is 0, so x minus 0 is just x. And then f of x is x, and then dx minus integral 0 to 1 2 pi x, g of x is x squared, d of x. And 2 pi on both of these can be pulled out in front of the integral because it's a constant. So it would be 2 pi integral of 1 to 0. And then x times x would be x squared and dx minus 2 pi, pulling out the constants, integral from 0 to 1. X times x squared is going to be x cubed dx. So now we can integrate, which would make it be 2 pi integral of x squared is x cubed from x equals 1, x equals 0. minus 2 pi again. Whoops. 2 pi x to the 4th over 4 from x equals 1, x equals 0. Since these are both 0, it's just going to turn out to be 2 pi 1 cubed is just 1, so it's just going to be 1 over 3, and I don't need to put minus the 0 because it's just going to factor to 0, so you can leave it as this. 2 pi 1 to the 4th is just 1 over 4, and again there's a 0, so you don't need to worry about that. So when you subtract this, this becomes pi over 6, which roughly equals 0.5236. This is problem 5. Integrate by definition. Find the integral from 0 to 4 of 2x dx. So we have the formula, or this is the definition of the integral. So first thing is you have a, b, and then f of x. So a is the lower bound, which is 0 right here. B is the upper bound, which is 4. F of x is just 2x. So now we can plug in. So this becomes the limit as n approaches infinity of b minus a, that's 4 over n, of f a is 0 plus k plus k times b minus a, which is again 4 over n. And then this can be rewritten as the limit as n approaches infinity, 4 over n, as k approaches 1, and then this can also be rewritten as, the inside of this can be rewritten as 4k over n. So it'll be f of 4k over n. When you plug that in over here, using the f of x, it becomes 2 4k over n. Then this can become 8k over n. This simplifies into limit as n approaches infinity of 4 over n. And then you can pull out, since this is a constant, this can become, I can rewrite it to make it nicer, 8kn. So this 8 and n can be pulled out because we just need the k alone. So this would be 4n times 8 over n with the sum, that's k equals 1 to n of k. So this sum is exactly what we have up here, and this can be rewritten as n times the quantity of n plus 1 all over 2. So 4 times 8 equals 32 over n times n, and then again the summation becomes n quantity n plus 1 all over 2. So this n can cancel out. This 2 can reduce this 32 into a 16. And then it becomes the limit as n approaches infinity of 16 over n. 16 quantity n plus 1 all over n. Again, this can be rewritten as limit as n approaches infinity of, this can be distributed 16n plus 16 all over n. But since as we're going to infinity, we don't need to worry about what's happening. We only need to worry about the leading terms. So this 16 doesn't matter. So then it becomes the limit as n approaches infinity of 16n over n. These n's cancel out, and then this just becomes a constant. So limit as n approaches infinity of 16 just equals 16. This is problem number 6, fundamental theorem of calculus. Find the derivative of the integral of 2 to the integral of 1 to x squared of cos t squared dt of e raised to the t raised to the third dt. So the derivative, when you take the derivative of an integral, these two cancel out, and then you take the integral, or you take this in terms, everything that's here becomes in terms of the upper limit. So this becomes e, and this t becomes in terms of the upper limit, which is another integral. So it becomes e to the integral of x squared, or from 1 to x squared, of cos t squared dt, and then that needs to be cubed. But then you need to take this, then you need to multiply by the derivative of the upper limit, and that would be dx of the integral of x squared 1 cos t squared dt. So just like we did over here, this is going to become in terms of the upper limit. So it's going to be cos, instead of t, cos x squared squared again. And then you need to multiply it by the upper limit again. So this would become e again, upper limit of x squared to 1 cos t squared dt cubed times cos, instead of t, x squared squared again, and then times the derivative of the upper limit, which is just x squared, and that derivative of x squared is just 2x. So the final answer is e raised to the integral of 1 to x squared of cos t squared dt all cubed times cos x squared squared again times 2x. This is problem 6, part B. Find the integral from 0 to 2 of the derivative of e raised to the secant of x dx. So these two cancel out, and then it becomes e to the secant x, but they need to be evaluated at x equals 2 minus x equals 0. Since x is equal to 0, we only need to worry about x equals 2. Oh wait, no, I'm sorry, this is secant, never mind. So it becomes e raised to the secant of 2 minus e secant of 0. And this is the final answer. This is problem 7a. Find the arc length of f of x 2 over 3 quantity x minus 1 raised to the 3 over 2 from x equals 0 to x equals 3. So we have this formula, arc length, which is the integral, gives you the arc length of, and is the integral from a to b, square root of 1 plus f prime squared dx. So first we need to find f prime of x. So the upper limit or lower limit a is equal to 0, b is the lower limit equal to, or the upper limit equal to 3. And then this is our f of x. So we take f prime of x is equal to d of dx of 2 over 3 x minus 1 raised to 3 half. So this is what we're trying to find. So first, I'm taking the derivative. This goes, or this can be pulled out first. And then it becomes x minus 1 over 3, 2. And then when you take the derivative, the exponent comes down, the exponent rule. So it's now 3 over 2 quantity x minus 1. And then this becomes 3 over 2 minus 1. Simplifying this out, these two numbers will cancel. There's a 3 here, 3 here. Those will cancel. 2 here, 2 here. That cancels. So all we're left with is x minus 1. And then 3 over 2 minus 1 is just 3 over 2 minus 2 over 2, which is just 1, equal to 1/2. So this is raised to now the 1/2. That's f prime of x. So now that we have f prime of x, we can start plugging into the arc length formula. So we have integral from a to b, which is 0 to 3, square root of 1 plus f prime squared. F prime is x minus 1 1/2 squared, and then dx. So next, this can be rewritten. Integral from 0 to 3. This can be simplified. So 1 plus this part, or this part, becomes, so these are multiplied, x minus 1 to the 1/2 with a 2 on the outside. That just becomes 2 times 1/2, which is just equal to 1. And x minus 1 to the 1 is just x minus 1. So all that becomes a quantity of x minus 1 to the 1 dx. So we no longer need these parentheses. Now we're left with integral from 3 to 0, or 0 to 3. This 1 and this negative one cancel out. So we're just left with the integral of x. So now we integrate square root of x. First, you want to rewrite the square root as a power, which is x to the 1/2. That makes it easier to rewrite. And then this becomes, when you integrate, it becomes x to the 1/2 plus 1 over 1/2 plus 1, which is equal to x to the 3/2 over 3/2. To make it look nicer, this fraction in the denominator can be rewritten as 2 over 3 times x to the 3 over 2. And then this number goes, and this is all evaluated at x equals 3, x equals 0. But x is equal to 0 here, so that doesn't matter because it'll just evaluate to 0, anything times 0. So we just need to worry about x equals 3. So when you plug this into a calculator, 2 over 3 times 3 raised to the 3/2, this roughly equals 3.4641. This would be the final answer for the arc length.